I'm going to explain Hirttof's theoretical device. The speed of cation migrating towards the cathode and those of anions migrating towards the anode are not necessarily same, but the speed of cation moving away from the anode will be proportional to the fall off and concentration of this ion at anode. Similarly, the speed of an anion moving away from the cathode will be proportional to the fall off concentration of this ion at cathode. Hirttof's rule. The loss of concentration around any electrode is proportional to the speed of ion moving away from it. To illustrate the same, an imaginary cell is considered. The cell is divided into 3 compartments. Each plus and minus sign indicates one equivalent of corresponding ion. This is this imaginary cell, the anode compartment, middle compartment, cathode compartment. This is case 1, case 2, case 3, case 4. In case 1, before electrolytes, 13 pairs of ions, 4 being in each anode and cathode, 5 in the middle. In case 2, when only anions move, 2 anions leave cathode compartment and enter anode compartment. These 2 leave the cathode compartment and here it entered in anode compartment. To maintain electrical neutrality, 2 cations from the cathodic compartment and 2 anions from anionic compartment are liberated. In case 3, when cations and anions move at the same rate, let 2 anions move from cathodic compartment to anodic compartment and 2 cations move from anodic compartment to cathodic compartment. In both AC and CC, there are 4 excess ions which are liberated to maintain electrical liberty. When cations move at double the speed of anions, 2 cations move from anionic compartment to cathodic compartment and only 1 anion moves from cathodic compartment to anionic compartment. The number of ions discharged at respected ions is 3, but the concentration of ions in the 2 compartments is different, which arises because of the difference in the cation and anion. The fall in the concentration of electrolyte in the cathodic compartment is proportional to the speed of the ion. Again, thus the fall in the concentration of the electrolyte in anodic compartment is proportional to the speed of the cations. Number of the equivalent of the electrolyte lost from the anodic compartment is U. Number of equivalents of the electrolyte lost from the cathodic compartment is V. It is U by V. Then the number of equivalent of the electrolytes lost from the anodic compartment equal to U divided by the total number of equivalent of electrolyte lost from the 2 compartments, that is U plus V. Altogether U by U plus V equal to T plus equal to U by U plus V and T minus equal to U plus U by V. The above is called as Hirttoff's rule. Determination of transport number, Hirttoff's method. This is the experimental setup of Hirttoff's method. cathodic compartment, anodic compartment, middle compartment, cathodic compartment, the AgNO3 platinum Ag coulometer. The apparatus is filled with standardized electrolyte solution in current kept loose to minimize the thermal effect. This passed through the solution for some time. The total amount of electrolyte is passed in coulometer. Post electrolysis, the solution are drawn separately from 3 sections of the cell and analyzed. Suppose x1 gram of AgNO3 in 500 cc of solution was taken in the Hirttof cell using platinum electrode after electrolysis. If 500 cc of anodic compartment solution, X2C of AgNO3. If Yg of Ag was deposited on the cathode, T plus or TAg plus. TAg plus equal to moles of electrolyte lost from the anodic compartment by total number of moles of electrolyte loss. அது எப்படின்னா amount of Ag deposit on the cathode equal to Y by 107.88 gram mole per minus 1. Decrease in the amount of AgNO3 in the anodic compartment equal to x1 minus x2 equal to x3g. Then number of moles equal to x3 by 169.87 gram mole per minus 1 equal to Yag plus. So TAg plus equal to Yag plus by Yag and TNO3 equal to 1 minus TAg. Disadvantage of Hirttof's method. Diffusion of electrolyte which occurs due to the development of concentration graduate the flow of current. Only small amount of the current must be passed as large current can produce convection which mix up the solution.